Data Structure and Algorithm Lab, experiment number 6. In this lab, you are asked to implement a doubly linked list and like a doubly linked list with five basic operations. So before going on to the code, I'll just show you the output. Just a minute. Yeah. So here. So like in this program, we actually have 8 options. The first option is insert at front, then insert after the given position, insert before the given position, then insert at end, then delete at any position, front, back, or any given position, then display from front and display from end. So okay, the 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 first operation we're gonna see is insert at front. I'll give one. So let's give the data 100. So now let's print it 6. As you can see, there's like only 100 in the double linked list. One node is only there. So now I'll give insert after position. Say 0. Okay, say 0. So now if I give 6, it'll be like 100 and 0. Now insert before position. Position data would be 200, position 1. So now if I see, it will be 100, 200, 0. So this is also working. And now I'll just give uh, back a print option. So this is back printing it. Then after that, I'm gonna give insert at end. So I'll give the data 400, and now I'll display it from end. As you can see, this also works. Okay, now let me delete from any position. So say I get 5, and I get position 0. So this should have deleted from the first position. Yeah, it has. 100 has gone. Now say deleted any position, I give any random position. Say 100, which is not even then the W link list. That'll pop up, they'll actually pop up an error showing sorry the given range, sorry the given position is out of range. Last node will be deleted. Let's just verify that. So as you can see, the last node was deleted. In this place, if I'm right, we had 300. So now let's delete everything. Say delete 3, then delete 1. Now there should be okay. As you can see, it's showing list is empty. Now let's again delete that. Let's see if the edge case works. Say 1. As you can see, it's showing list is empty. So that means once the list is empty, you can't delete. So everything works. Now I'll just go through the code. 8. 8 is to exit. First thing, I made a node using a class. So this is the node class which has 3 members: data, which stores the data; next, which actually stores the just a minute. next, which actually is a pointer to the next node, previous, which is actually a pointer to the previous node. Okay, so that's there. And here I have a constructor initializing the data with the value d, and initializing both next and previous to null. So I implemented the entire w linked list as a class. So this class has two. Uh, it actually has two variables. First the front pointer and then the end pointer. And this is actually a constructor. So this initializes both the front and end to null. First function will be insert front. Insert front receives the data, then it makes a new node with that data and stores that in the variable n. Now n of previous should be null, as it's the first node. The previous of the first node will always be null, and n of next should point to the current front. So that's that. And if the current front is double equal to null, that means the w link is empty. Then we initialize uh, end also to point to uh, this n. So like see, if it's initially null, that means there are no elements in the list. So as soon as we insert this element in the list, both the front and end should point to this element. So that's why we do this. If that's not the case, then we just say front of previous would be equal to null. So if there's at least one element in the w linked list, then we take the front of it. So if there's only one element, this would point to the first element. So the first element's previous would be equal to n. So that makes a two-sided connection. And then finally we initialize front is equal to n. So this is insert front, then insert after. Okay. Insert after is like this. So we have two arguments, position and data. So if front is double equal to null, that means the double linked list is empty. In that case, what happens is I just print list is empty, adding new elements in the front, and I just call this function insert front. That will do the job for us. But if it's not empty, then I need to use an iterator to point to the element. I actually need to use an iterator uh, to the uh, node that corresponds to the given position. So I go to the node. If while going to the node, if I find that like in some iteration the current node of next is equal to null, that means the given position will be out of range, right? So like imagine the last node, and we have to go to the okay, imagine a double linked list with one node, and the given position is say say 3. So like while this loop is running, first thing it'll point to the first node, then you'll check if itr of next first of next is equal to null. Yeah, it is equal to null. That means the double linked list ends there, and there is the given position exceeds the size of the double linked list. So in that case, we print this error message and we insert it at the end. So I will go to this function later as we move on. So like this is actually an edge case. So like see, imagine if count is equal to 0 and the position was uh, mm, position was 0. Yeah, position was 0. Yeah. Okay. Yeah. Imagine count is equal to 0 and the position was 0. In that case, this will print as even in that case. Okay, in that case, we actually don't need this line, but it it does this same job. So basically, inserting at the last. So this would work, and next thing would be okay, yeah. Uh, if in case the given index is between the range, say the maximum size of the double link is 5 and we need to insert the third position, then we'll come here, we'll make a new node. Okay, then the new node's previous should point to the ITR. Okay, as this is after the current position, so new node's previous will point to ITR, then new node's next should point to ITR of next. Okay, so this makes a this makes a this makes a connection by the with the new node, but then the former connection will will still be there. So we actually need to change that. So ITR will be equal to ITR of next. Uh, I go to the I go to the I go to the next node of ITR, then make the previous point to end. So this side, the the connection is linked. Now we need to focus on this side. So then ITR will be equal to n of previous. That will again point to the same element initially, like same node initially, uh, like like pointed after this operation. So and we make that next as n. So both the sides we make the same connection. Insert before next function is also similar. Only difference would be you would have only difference here would be one position before. So here you could see position -1, and for the first like if it's before the first element, there'll be an HK. So for that alone, we have this function. Otherwise, it's the same, no change. So insert end would be it has one argument data. Just a minute. It has one argument uh, data. Sorry for the cut. So end has one argument. So initially we are making a new node with the given data and storing it in the pointer variable n, and we initialize n of next as null. Like if you see the last element, that is last elements next will always be null. So then we say n of previous would point to the current n. When we say if n is double equal to null, that means there are no elements in the double linked list. So in that case, we just have this one condition: front is equal to n. As I told you, uh, is if there's on there's no element in the linked list, and if you're adding one at the end, then we use this condition, like so that both the front and end will point to end. Else, just the current end of next pointing to the new end and update the end. Then I have this function to delete the first node, and this is to delete the last node, which I'll be using in the delete position. So basically have a temp variable, uh, make the current front to front of next, and delete the temp, this temp initially as the front, and make uh, the the updated front of previous equal to null. Same thing here, only thing would be change will become end, and wherever there is next will become previous. Wherever there is previous will become next. So delete position as one argument, the position. So we have the first condition if it's empty, that means front is equal to null. Then if both front and end is equal to the same node, that is if there's only one element, then delete that element and make both front and end point to null. Last one would be have an iterator go to the current position minus one place. So say if the current position was the third position, so I need to go to the second position. Until that, this while loop will execute. This is if condition. If say the like as I told in the like insert thingy, if say the position is 4 and the total size in the linked list is only 2, then this prevents it and just deletes the last node. This is an edge case, same thing. Yeah. Okay. If position is equal to 0, if it's the first thing, then just delete the first node, because like this is an edge case, it won't work with this, so I had it this thing. Then if iter of next is equal to null, uh, like imagine you have a link with two elements, and iter is pointed to the first element. Okay, so normally when you delete, what you will do is you will delete the second element and make the first the third element point each other. But if there are only two elements, in that case uh, you only have two elements. In the third node's position you have null, so I'll pop an like 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 that'll actually pop up an error, so it's an edge case. Other than these edge case, the normal process is have a temp variable point to the iter of next. Okay, the 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 node that is gonna be deleted, then iter of next should be equal to temp of next. That is initially itr is one position before the element to be deleted. So so that node's next should point to the uh, element to be deleted nodes next. So that's this. Then delete the element to be deleted. Then make temp equal to the itr, that is the node previous to the element that was that was deleted. Then make itr go to the element that was deleted next. So and then make itr of previous, that elements previous point to 10th. That is the before element of the element that was deleted. So this is this. Forward traverses basically have a pointer starting from front and traversing until iter of next is double equal to null. That is the last element. Until the last element, just traverse and print the data of the current node and make the iter point to the next node. When the last node reaches, we just break out of the loop and just print the data of the last node. If the list is empty, then this is satisfied. Backward traverse is the same thing. Only thing is, instead of front, we start at end. That's it. So this code is for that identification mark I showed you, the Daniel thingy, to show that this code belongs to me. Then here I initialize the W linked list class. This entire thing is a class. Initialize it and have it as a variable list. Here I have two variables, choice and position, for later use. First, I ask the user what choice they want to make. It will be stored in choice, and this while loop is being entered. While it's not equal to 8, this while loop will run. So inside the while loop, I have a switch case based on the choice. each statement will be executed. Say, like for example, if it's inserted front, so it will ask the data to be inserted front, store it in temp, and just use a function insert front in the w linked list class. Say if it's after insert after position, so we'll be having one more variable position, so we'll also get that input from the user, then call the function insert after. Similarly, all the functions, same thing goes here. So, and I have included a default condition if the user enters say some random number other than 1 to 8. Now after this is being executed, then the same menu will be printed again. Choice will be taken and while loop executes again. If the user gives 8, then control exits on the while loop and the program ends. This is the entirety of the program. I hope I explained it. Thank you for watching.